to get started properly. Derek, you good to go?
Okay, great. Hey, welcome everyone. Just going to run through a bit of an introduction to Rails security today. I want to emphasize the introduction. There is only about an hour we've got to talk today, and this is something that I can do an entire kind of day course on. So this is very much a light brush over the surface, but I'm hoping it gives people some insight into what they need to be aware of. I'm Tim Goddard, a pen tester at Aura Information Security. So my job day to day is to go into various businesses, various government departments, so on and so forth, and break into the systems that they have. So exploit their applications, break into networks, so on and so forth. And the purpose of doing that is then to write reports telling people where the holes are, what they need to go and fix to ensure that other people can't go and do that in the future, at least quite as easily. I'm also involved in our training team, where we do run various courses from time to time, going through the OWASP Top 10, going through the vulnerabilities that people need to be aware of in their applications. And I used to be a Rails dev, hence the talk on Rails today. I started writing Rails in 0.9 and was on my first project when 1.0 came out, then took a big gap through the 2 era, which was worth missing. But it's come back to a fairly decent standard these days where the features actually work. So I'm happy to be involved in it again. So the way I want to go through things a bit today is I want to first go through the common kind of web vulnerabilities, the things that we see everywhere, not just Rails applications, but all the different types of applications that we write. And just go, what are the issues? What does Rails try to do about them? And some of the limitations of that, where the protections that Rails includes for us kind of falls down. I then want to go into a few Rails-specific issues, again, not too much depth, but things that we tend to see particularly in Rails applications, and then just a couple of tools that you can go away and run against your own apps tomorrow. So, I mean, why would we use something like Rails? What's the purpose of using an application framework? Rails is a really invasive application framework, and by that I mean it makes the decisions for us, and you'd better not go against them, right? You hand over a lot of your core decisions, how you're going to do your templating, how you're going to handle raw requests from the browser, so on and so forth. You hand over these decisions to the framework, and in return for following the way it wants you to do this, it can do a whole lot of things for you. It can automate a lot of the process. So it automates all the common cases. The idea is to speed up development, make development more consistent so developers can work together better, and make development faster and more reliable. Security-wise, by handing over these decisions, we can help the framework to provide us with some protections by default, where it's relatively difficult for something that's not so invasive, like raw PHP, to introduce protections by default. They failed miserably with things like magic quotes. In Rails applications, because the framework gets more involved in the decision-making process, they can tell us, follow this and you'll be all right. So the common vulnerabilities, I can't go through all the OWASP Top 10 today. I just want to cover off some of the most common and worst ones. And one of the ones we see all the time that's absolutely devastating is SQL injection. Now, apologies to the regulars here. I want to explain briefly what this is. So the idea is that we're running some query against the database. We're retrieving some records, and we've got some condition, and that X there is something that we're allowing an attacker to control arbitrarily. So they can set that to whatever they like. Our intention is that we set our artist to Justin Bieber or something, and it returns a list of results, right? But what someone actually ends up doing is they insert a query fragment. So they insert something else in here, which instead of just retrieving Justin Bieber's latest hits, goes off and retrieves information from a completely separate part of the database. This is an extremely severe class of vulnerability. In general, if you have one of these anywhere in your application, then someone can read your entire database through it. If it's in the right place, they may be able to write anywhere in your database through it, or with particular database engines like Postgres. More features, more problems. So one of these vulnerabilities is a massive issue in and of itself, even without any other issues in your app. So what Rails encourages us to do, and this is an example of it being relatively opinionated, is it says, right, you're not going to write raw SQL, you're not going to write queries yourself, you're going to write Ruby code that looks like this. And the framework guarantees that if you pass your parameters in like this, if you don't try to build up the queries yourself, but follow their particular framework, that they will handle all of those values safely. If the user passes a number, if the user passes a piece of text, whatever happens, the framework will handle these particular cases safely. We've got a couple of examples we can use. We can either use just build a query like that, record where artist is that, or we can write a query with placeholders in it, and that's what this question mark is here. It's a placeholder for a parameter we want to put in. So it's something we're relatively familiar with in most languages, but it provides this as a way of writing queries safely. So when an attacker tries to inject into a query like this, instead of being able to add their own bit of query, the framework ends up escaping all of those quotes, making them safe, making it so they're only interpreted as text. And that's specific to every different database engine we use. So it can be quite difficult to do right yourself. There are a few limits to this approach where this doesn't work. The first one, obviously, is where we go back to the first example and we just write queries by ourselves. When we're building out queries by concatenating pieces of text, really the framework isn't seeing what we're doing. It isn't involved in this process, so it can't protect us. So warning sign anytime you see a query with pluses through it, right? Really significant warning sign. This is probably not safe behavior. Equally, if we allow the entire query to be passed into our application, for example, we build up a set of conditions in JavaScript and just go, here, run this query please to our application, obviously that's also still going to be vulnerable. It may sound silly, but I believe KiwiCon had free pizza one year thanks to Hell Pizza having done exactly this in a Flash application. Yeah. So another limit of this is there are certain methods in Rails, and I don't have time to go through a list of all of these. There are certain methods such as order, which will be the most common one we would see, where actually it's not just accepting a name of something to sort on, it's accepting any SQL fragment that you care to pass into it. It's really important if you're constructing queries in Rails just to check out which ones are safe and which ones aren't. You can read through the docs, any of them that say this accepts a SQL fragment, probably not safe to let someone else control, yeah? And there's a really good list here at rails-sqli.org of which methods are safe, which methods aren't safe for use and to allow an attacker to control like that. So SQLi guidelines, never build SQL queries by concatenating strings. Really simple. You can always write the same query using placeholders. It's just a matter of reorganizing things a bit. Use the built-ins helpers wherever you can. Don't try to write database queries yourself because that's not what the framework wants you to do, and look things up. The other thing to do is we really like to push defense in depth to encourage people, rather than relying on one protection in your application, actually consider what's going to happen if there is this type of vulnerability. So you go, if there is a SQL injection vulnerability, then the attacker can do anything that the database account is allowed to do. So don't give your tiny little web application access to all tables in your big corporate database. Yeah, it may seem like a joke, but we see this. We see people going, oh, I'm just going to add some WordPress tables into my CRM database. It happens. So limit what your application is allowed to do, limit what your application's database account is allowed to do as a way of defending against these if the first line of defense falls. Our next type of attack, it's actually quite closely related. These are both different types of injection attacks, really, is cross-site scripting. So again, this is an example of where we've got, in this case, a piece of an HTML page. And we're allowing the attacker, because they can pass some parameter that then comes back in the page, or for whatever reason, the attacker has control of this. They can type their name into a box and it comes out here. So the case we're looking for here, the case that we want our legitimate users to follow, is that someone signs up to this page and they say, hello, I'm Justin Bieber, and it comes out and says, welcome back, Justin Bieber, right? However, what an attacker ends up doing is they decide that their name is script source equals blah, 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 and instead of it welcoming the user back, it runs the script. So the threat of cross-site scripting is where SQL injection allowed an attacker to take control of the database. Cross-site scripting allows an attacker to take control of one of our users' browser sessions. So if they can cause this to appear in someone else's session, it's not terribly interesting if they can cause it to appear only in their own session. If they have to register with the name, blah, blah, and only they see it, unless they can trick someone else into logging into their account. But where it gets more interesting is where you can cause this to appear in a different user's browser session. And at that point, you can take control of their browser session, you can read everything in the pages, you can perform any action they can perform from their browser, because as far as the browser is concerned, scripts running in a web page are the user. They run with the privileges of the user. Cross-site scripting is not just in the context of I'm dropping something into the middle of an HTML page. Sometimes we end up with things in an attribute, in an HTML tag. So we've got, in this case, an image. And we might want to say, for people who need a screen reader, instead of showing a picture of this user, I want to show their name. So that's what the alt text in an image is for. So in this case, we've got something inside these quotes, inside an attribute. We could also have injections like this in JavaScript. So we could be generating JavaScript on the fly, and we're allowing something in here to be controlled by the attacker. All of these will result in the same thing, the user's browser session being taken over. So what does Rails do to try to help us with this particular case? When we want to write that first example, when we want to say welcome back someone, in Rails we do it with an ERB template like this. So we have a file like template.html.erb, and we have these tags here which say run this bit of Ruby code and put the result in the template, right? Now when we do this in Rails, Rails goes, this is an HTML file. I'm going to apply HTML encoding by default. And the effect of that is that instead of breaking out, doing nasty things in the page, it encodes quotes as HTML entities, so on and so forth. And this encoding results in a literal character appearing in the page. So if you say my name is, quote, your worst enemy, then you hover over that image, it'll say, quote, your worst enemy, right? It's not, it ensures that it's interpreted as text, not as page content. Where this starts to run into issues, where Rails can't defend us again, is whenever we start building HTML, like the queries, whenever we start building HTML without using its template system. We're saying it's an opinionated framework. It says this is the way you're going to do things, and if you deviate, it won't protect you. So this is a case, something that I've actually seen, not exactly code as it sits here, but someone had written what in Rails would be called a helper method. And what they wanted to do was, it was an accounting, financial system, and they wanted to say negative numbers should be read and in brackets. And you encounter business rules like this all the time when you're building applications. Negative numbers should be read and in brackets. And in this particular case, because the HTML for I want this to be read and in brackets was being built in the helper, in the Ruby code, rather than inside a template, it was being built in a way that the default protections didn't apply. And someone could inject their own HTML, their own scripts, and take control of another user's browser session. So you would come along in a case like this, and you would set your amount to to be a piece of text instead of a number. So this code has assumed it's a number. In the particular case where I encountered this vulnerability, yes, it could be a number, but an attacker could also trick this, force this to be something other than a number. And that's where the issue resulted from. Say assumptions, built-in assumptions of I'm going to assume this is a number, are really, no pun intended, a number one cause of these types of issues. Another limitation of this is that when I said Rails applies HTML encoding, this encoding is safe only for the case of I don't want HTML code injected into my page. What this doesn't protect us from is cases like I'm going to create a link to something the attacker controls. An attacker can supply my homepage address as this, and then that gets included in there. Well, it turns out that you can bake JavaScript into a link as part of this. So when someone clicks on it, it will run a piece of code instead of opening up a new window. Equally, if you have script tags in your page and you have an inclusion within those script tags, it's not aware that this is no longer just HTML. JavaScript has special meaning here. It's not context aware. You may have encountered some frameworks like AngularJS attempt to be context aware. Rails, which means that when it sees that opening script tag, it goes, oh, I now know what I need to do in this context. Rails doesn't do that. It ignores everything that's not their special inclusions. So this particular case would be extremely dangerous. Very easy to inject whatever JavaScript you want in that particular case. Examples that aren't so obvious, things like CSS styles in particular browsers can actually include code that will run like JavaScript, so on and so forth. You could be able to write a style that injected a piece of HTML somewhere else in the page. These particular types of cases you want to be really careful with. Because most of the time when we come along and test things, we'll catch these, but they're actually really quite hard to find sometimes until an attacker does 2 years down the track when the tools have gotten better and suddenly someone's attacking your site. So the important note to observe here is that Rails applies a simple assumption, which is any file called .html.erb contains HTML code and only requires protection for HTML. If you have link addresses, if you have JavaScript, if you have styles embedded within that page, it's not necessarily safe to put anything that your end user, a potential attacker, controls in those contexts. A third limitation is that, like any of these protections, we can explicitly bypass them. There's a raw keyword or its function that marks a particular piece of text as safe to include in the page, and we use this when we want to very explicitly say, yes, I know this came from a safe source. Well, keywords like this we use to include the example 2 slides back, that, right? So it was saying, yes, I trust this, I know it's a number, just throw it in. You don't want to be doing this unless you have 100% backed up guaranteed that something is safe. .html safe is exactly the same. In fact, that uses that under the hood. And the strange and little known that no one in the Rails community seems to know about percent double equals also bypasses the entire escaping mechanism, tells it just include this raw thing. And that's even worse than that because it's not verbal, it's not explicit, it doesn't say what you're trying to do, right? In fact, none of these really do very well. Raw token, HTML safe, random symbols, none of them say, I really, really know what I'm doing here, I want you to do something that could be dangerous, right? I tend to be a fan of languages that make you write this out and say, you know, dangerous include, or something like that. Yeah. So the escapes are applied for, that's relevant. So what do we do in Rails? What approach should we take to avoiding cross-site scripting? Whenever you can, you want to be using the fact that Rails has a built-in feature called partial templates. You can just about anywhere in your code ask it to render a little micro template that just contains a formatted number or just contains a user profile block or whatever that might be. Partials are for templates that you reuse through your application. You should, wherever you can, be using this instead. Keeps you a lot safer. Whenever you're using URLs, whenever you're allowing someone to enter a URL into the page, that's a very dangerous spot to be in. Ideally, you don't include links to external sites that your users have typed in at all. If you must, you want to be applying some form of whitelist, saying it has to be an HTTPS or HTTP site. It can't be a JavaScript URI or a data URI. It has to begin with this. Again, whitelist, don't blacklist. If you blacklist things, that's to say this thing is banned, people always find something that's subtly different and therefore not banned. Whereas if you say explicitly this thing is allowed, that's the point when you can actually rely on something being true. This URL will begin with X. Wherever you can, you don't want to be mixing styles, JavaScript, and things into your HTML pages. I hate inline script tags inside HTML pages, and I've been guilty of using them as well, right? But there is really no need to be doing this anymore. All your JavaScript should be in external files. You flip them off to your CDN, whatever you want. Don't generate these things dynamically if you possibly can. Wherever you have complicated contexts, so I've got CSS in style tags in HTML, that's actually a relatively hard thing to escape right, especially when you start to deal with things like JavaScript tags, according to the HTML standard, implicit C data, which means that if you apply HTML escaping to anything inside a script tag, it mangles it. So you actually end up with particular cases where you have to get rid of this and these particular expressions. Anyway, it's really hard to do right. So just wherever you can, avoid it. Where it's absolutely necessary, we have to do the encodings, but it can be extremely complicated to get right. We struggle often to come out with the correct advice for people in these particularly complicated situations. That's with a lot of experience in what is and is not vulnerable. But you also have to consider what does and does not actually work, which is often a different thing. And again, we like to push defense in depth as a strategy. Please don't rely just on, I'm going to get this right everywhere. I really want people to consider using content security policies. Now, these are just a header that you can include in all of the responses from your web server, and they say, please ban the use of eval in JavaScript. Please ban using inline scripts in pages. Only allow scripts to be loaded from these domains, only allow images to be loaded from these domains, and it can set down an entire policy about where the content in your page is allowed to come from and what that content's allowed to be. A solid content security policy, and there are ways of rolling these out fairly safely. A solid content security policy is a really good backstop. For example, GitHub, which a lot of us probably use, had a cross-site scripting vulnerability, which a researcher found. However, the fact that they push a content security policy with every response meant that this vulnerability was not exploitable at all. They did not have a window of vulnerability. The researcher said, hey, you've got this thing that would be vulnerable if you didn't have a CSP. And they said, thanks, we'll fix it and give you some money for reporting it. They didn't have a window of vulnerability because they had a backstop behind that first line of defense. The next class, which I won't go into too much detail on, is cross-site request forgery. This particular issue is where we've got some form on our site which allows us to make a transfer. In this case, we're making a transfer from one account to another. So we've got some action on our website. Someone else goes and writes this form on their own website. So it's entirely legal on the web for me to create a form on my site that I fill in and post off to yours. There's nothing banned about this. There's nothing to stop this inherently. And when that form is posted off to your site, your browser will come along and say, the user's logged in, I know they're logged in, they have this valid session, and it'll pass along all their cookies attached to that request, right? So as far as your web server sees, this request came in saying, I want to make a transfer from here to here. So how do we know that that actually originated from our site? That was something the user said I wanted to do, as opposed to something which someone else just stuck in a form on a page and wrote a tiny bit of JavaScript to automatically send off. So Rails uses a protection method, the protection method really, called CSRF tokens, which is when a user goes to your website, it hands them back, hidden inside their session, a CSRF token. This token then has to be presented with every post request, every data changing request that that user wants to make. Unless someone else can predict this, unless they can intercept it, which usually requires having a cross-site scripting vulnerability, our last example, then they can't forge these requests. The framework sees the request come in, says it doesn't have the right token attached to it, throws it out. And actually the default, the major Rails authentication framework device can be set to completely and utterly trash the user's account when someone tries to do this. Log them out, gone, to make absolutely sure that nothing can be done using their account against their will. The limitation of Rails protection here is that it makes certain assumptions, which are assumptions that are baked into the HTTP standard by which we talk to web servers. It says when we make a request, which is a GET request, in other words, all the data, all the parameters are in the URL. When we make one of these requests, we don't expect the page to go and start changing data. However, when we make a post request, when we make a create request, delete, update, these are all data modifying verbs. These are all saying I want to change something, and Rails goes, right, I assume you want to change something, so I'm going to check that you've authorized it. And that's the point that this kicks in. So really, what Rails can't protect you from is where you've, in a GET request, in a page that Rails thinks should be listing things or showing you a record of something, if you're going and changing data, it doesn't know about this. A pattern to avoid, and this was present by default in every Rails application until I think 2. A pattern is still present in the first Rails app I ever wrote, is that you have something like this. Now match means accept any verb, accept get, accept post, accept create, whatever, and follow this particular format to say I want to do this. If you have this in your config/routes.rb file, if you have that in there, then a user can do anything in your site through a GET request. CSRF protection goes out the window. And one of the key things that I've been doing in terms of internal training at our company and in terms of trying to teach other pen testers is to find and predict and exploit this default case. So it will come up. It will come up. The next example here is direct object reference. Now, this is drawn from a real example, something I found in a production public-facing application. I went through a checkout process and I noticed, oh look, there's invoice ID equals blah, 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 blah in the URL bar. So I went, what happens if I subtract 1 from the invoice ID? Well, it showed me someone else's invoice. What happens if I write a script that goes backwards for the last 10,000 invoices? Well, I got about 8,000 valid ones, right? I went to the client and they said, oh, that's not really in the scope, is it? It's been live for 10 years. That no technical ability required whatsoever to exploit this, right? I saw an invoice number, I changed it and gave me someone else's invoice. That's, I mean, anyone could have done that. People probably did over that 10-year span, right? Now, unfortunately, Rails doesn't provide us with any protections for this case by default. This is a key type of vulnerability we see a lot of in Rails, because when you make certain things in the security world easy, people start to get relaxed. They start to forget that they need to be on their guard, and then something like this crops up. So it's something we see time and time again. You make it easy to manage users, easy to log in. People forget to check what the users are allowed to do. People forget to check what resources they're allowed to access. So a really key thing is to be throughout your application, being aware that actually you can't necessarily trust everything the user's provided. So really the solutions to this are, the solution we tend to recommend people use first is an expression like this. I want to first get the list of things the user is allowed to view, and then run the search for the thing they've asked for. So instead of saying I want to get the invoice, I've got an example, but instead of saying I want to get the invoice with this number, say I want to first get the list of the user's invoices and then filter it down to the one they've asked for. What this guarantees is that if they ask for something they're not allowed to access, the application acts as if it doesn't exist, which is the optimal behavior, leaks the least information possible out of everything, right? Rails is particularly bad with these direct object references because it has a habit of numbering things 1, 2, 3, 4, 5. It's an opinionated framework, so it tends to be particularly easy to exploit these. So narrow it down to what the user is allowed to see, then run the query they ask you to. Same thing applies to a search, right? If I can break my search into 2 fragments, and I saw a client doing this very well, not in Rails, in PHP, but they were running in a search engine. You're allowed to type in a bunch of things. They said, right, first thing is I'm going to take it, I'm going to stick in a bit that says these are the types of documents you're allowed to look at. And then I'm going to go and add your search terms on as a second separate set of conditions that can't override those first ones. And that's really important. If you must, and unfortunately the major Rails framework for doing this, which is called can, does exactly this. It was can, and then it was can was the successor. But if you absolutely must, then you can have a piece of code somewhere that says, is a user allowed to view this record, and then check it wherever you're handling that record. Doing this is pretty fragile though as an approach. You can do both is good. But doing this is pretty fragile as an approach because you have to remember to do it absolutely everywhere. And if you miss one case, if you forget to check on delete that a user is allowed to access the record, then someone goes, yeah, I'm going to delete all your records. Yeah, people are perverse, they will do it. Yeah, so, but best option is filter first, query second. So these are just the things that we see in all applications, right? I want to get into a few things that are Rails-specific issues. These aren't necessarily things that can only occur in Rails, but these are things that occur very easily in Rails or that we see a lot of. One of them is called mass assignment. So Rails has this idea of wanting to help you construct forms really nicely, right? So it has a bunch of helpers that will help you build up a form, and it results in something like this. I've got, sorry, this is a bit too much to put in the slide, but I've got something that says I've got a text field here and it's supposed to contain your first name. I've got a text field here and it's supposed to contain your surname. And then my Ruby code just says retrieve the account that you were talking about and set the things that you provided to blah. This is following the dry principle, don't repeat yourself. It's trying to avoid having to explicitly say, I want to update the first name, I want to update the surname, I want to update the so on and so forth on the account, right? It's trying to avoid including unnecessary verbiage in your code. However, what an attacker can do in this sort of case is the attacker is in control of the browser. Anything that runs inside their browser, they can modify, which means they can modify that form. They can add fields into that form. So imagine you've got a balance on every account that is supposed to represent how much credit that that particular user has with your store. And imagine that you've got this particular code here doing the update? Well, they just add in a balance field into the form and send it off with $1 million as the content, right? And we see these vulnerabilities quite a lot. Rails has gone through a whole series of different protections to try to close this gap, and we appear to finally be coming to the end of it with a solution they call strong parameters. What this really is we're abandoning the whole concept that we can avoid repeating ourselves, and we're going to require you, every time you want to do one of these bulk updates without specifying things, we're actually going to require you to list the fields that you're going to allow to be updated. We went through a series of different approaches. First, we were listing which things you weren't allowed to update on a particular record. Then we were listing the things you were allowed to update, because it turns out when you blacklist, you forget things. And then people realized that actually an administrative user might need to be able to update different records, different fields on a database record than the person themselves. So that's why we ended up with this solution, which says whenever I process a request, I have to explicitly say, or should explicitly say, I'm going to permit these particular fields to be submitted. Strong parameters is a really good solution. It just absolutely kills these vulnerabilities dead in the water, whereas the other ones were only ever half measures. Another issue that we see in Rails specifically is that Rails has a really complicated input model. It's not just a case that when I provide a parameter to your application, it's going to be a number or it's going to be a string. It's actually going to be something that I, as the user, I, as the potential attacker, control. And one thing that I'm trying to encourage people to test for, and encouraging when they're testing Rails applications, is to try submitting different types to a form. And I've seen this in a whole bunch of production Rails applications. This here, what happens if instead of sending a name, like Bieber, what happens if I send an array instead? So it turns out that when I pass an array into a query, as I said, Rails promises to handle this safely. It promises to do magic special stuff so that whatever we pass into it, it's going to do something vaguely sensible and safe, right? So if I pass a list into it, it goes, oh, I know what you mean by that. I'm going to search where the name is any of these. Now, I've got an example that I get people to work through for a Rails training course that I run, where I get them to play a game, and they have to cheat at the game. And the solution to cheat at the game is to provide every possible option in a list. So that you always guess the correct option, you always get the right result. So I've seen cases like this, even if it's something along the lines of, recover my account where my forgotten password token is this. It's not going to be a huge deal because you can't inject arbitrary SQL code, but you could provide an entire list of possibilities and be able to carry out a brute force attack much faster than you might otherwise be able to. Solution to this is also strong parameters. This is why they're next to each other in the presentation, right? Whenever we apply something like this, what this is saying is I want to allow you to provide a first name for an account. First name, it guarantees, is either a piece of text or a number, or I think nil, but nothing else. It doesn't allow that to be set to arbitrary arrays, hashes of various objects, so on and so forth. So strong parameters are really something that you want to be using consistently. A lot of applications that have migrated from Rails 3, Rails 2, haven't fully moved over to these yet because they were introduced later and it's effort to update their applications, right? It's highly worthwhile prioritizing updating that wherever you can. Arbitrary object deserialization. This occurs in just about every language, just about every framework in some way or another. In PHP, if you run unserialize over something that an attacker can control, then they can take control of your application. I can't go into the details of how you do this. Suffice to say that I have a piece of YAML, which is a language that Rails can pass, which will execute arbitrary code in any Rails application. It's just as soon as you start doing things like this, YAML's the one to really be aware of. Marshall is another one to be aware of in Ruby. As soon as you start doing this, someone can actually take complete control of your application and run anything they want. Really, really careful with this. Likewise, obviously, some things shouldn't need to be said. I have, in a production financial application, seen someone deciding to use eval as a parser. I'm going to write something as if it were valid Ruby code and then eval it as a way of reading data in. So it was literally in the controller, take this parameter and eval it. It was absolutely terrible, and obviously remote code execution is the most serious type of vulnerability you can have. You want to be really, really, really careful of these particular cases. This particular case here, there was recently a vulnerability. I don't know if anyone's familiar with Swagger, which is a language for describing APIs. The Swagger library would allow you to download someone else's YAML file from the internet and read it in. Much to my embarrassment, I actually came across this during a client assessment, determined that the client was not vulnerable to it, and then forgot about it. And a month and a half later, so this particular client wasn't vulnerable to it. A month and a half later, it turned out everyone else was vulnerable to it. It's just that this client happened to be safe. It's really easy when you're doing a pen test to get tunnel vision and only pay attention to what affects the client you're working for right now. But yeah, that was a big one, and I missed getting any. It was presumably in the pipeline to be fixed already, so I wouldn't have gotten anywhere. It would have been, thank you for your report. We've already received that one. I want to get into a couple of things because obviously there's a lot to do here, and you could spend months overhauling a Rails application to follow even a simple set of recommendations like this, right? It's hard to keep code quality up while we're building things. But there are a couple of tools that you can actually just go and run tomorrow. Feed the results into your ticket system, yeah? First one's called Brakeman. So Brakeman is a static code analysis tool. It'll trawl through your Rails application and it will look for unsafe patterns in your code. It's really worthwhile running this thing. It'll do checks of whether your various components are out of date. It'll tell you if you're vulnerable to all of the things that we've gone through today. And it'll pick up some cases. It doesn't always get things right. It'll come out with a bunch of things and it'll say, I'm very confident about this one, but I'm only medium confident about this one. Usually when it says confidence medium, it means I'm guessing. Often those turn out to be nothing. Although I've had a case where someone said, oh yeah, we ran Brakeman, this is the report, they're all false positives. And I went, that one's remote code execution. So be careful labeling things as false positives. Investigate them fully, and if you can, get rid of the warning anyway, because usually if there's a warning kicking out, even if it's only medium, it's because something's not being done the safest way. Yeah, and it's really helpful. It'll break it down. It'll tell you exactly what line is dangerous. So in this case, this is what I was pointing out before with cross-site request forgery. It's noted that I've got match controller action ID. This is the case that allows cross-site request forgery against any endpoint in the site. This is one of the training exercises. This vulnerability was not intentional. So it was because I copied and pasted code from another application. I do it too. Everyone does it. The other one to go through, which I don't have as much experience with myself, but every time I talk about Brakeman, people go, "Oh, have you tried bundler audit? Oh, have you tried bundler?" So this one I've now tried, but so I don't have that much experience with. What it does is it goes through all of the Ruby gems, all of the packages that you're using in your application, and checks them against a list of known vulnerabilities. This is only picking out the things that are known, that are published, but it helps you to keep track of are any of the things I'm using in my application known to be vulnerable, which is, I think, A9 in the OWASP Top 10 is using components with known vulnerabilities, right? It's really hard to keep track of exactly what software we're using. This is a really good way of doing it for your Rails apps and for the Ruby code side of things. We're actually gone a bit faster than I expected. Do people have any questions leading out of that? No? Does anyone want to share any stories? Well, yeah. It's certainly not nice, yeah. I'm just remembering a little while ago there was an issue with was it GitHub actually not to get hacked because of Ruby vulnerability. Was that a massive sign vulnerability or who was that? So there was the one I remember in GitHub was there was a problem where you could have that YAML deserialization issue that we had before. This was present in every Rails application. They had known that YAML was dangerous, so had plugged the ability to provide YAML directly. What they hadn't plugged was you could send an XML document to any Rails application and tell the very, very clever XML parser that the contents of this node is actually YAML, and then it would pass it. So that was I can't remember, CV 2011 something, which was every Rails application was vulnerable to remote code execution attack overnight. That was not a good day for the Rails security mailing list. And people got very, very twitchy about using Rails for quite a while afterwards. But to their credit, they fixed it pretty promptly. And then people kind of went nuts researching anything to do with issues like that to make sure it never happened again. Yeah, GitHub were vulnerable. Ironically, Metasploit is one of the major exploitation tools were vulnerable. And they published a blog saying, we're vulnerable to the issue. By the way, we've written a Metasploit module to let you exploit it. So, which is their philosophy. They did exactly the same thing recently, actually. There was an issue where Metasploit, by default, if you installed it and failed to set it up through the admin UI, you could take it over remotely. So they wrote a module to exploit itself. Yeah, that's right. Yeah. So just, I mean, there's no magic behind any. Well, there's quite a lot of magic that tries to take place inside Rails, really, but it can't. Say the key point for today is it can only save you when you follow the method that it prescribes. So my personal philosophy is that following the way it prescribes is the way to go, even if you personally disagree with it. And even though I disagree with the way Rails does things on quite a few fronts, for that reason I would do it.
Cool. Well, let's all thank Tim for his talk today.